So this video is just to give a little assistance with the section 6.8 homework. It doesn't help you set up a picture for every problem, but over half of them. So I think this might be helpful. The first one I want to look at is number 1. So it says, Juan and Ramela are standing at the seashore 10 miles apart. The coastline is a straight line between them. So let's say here's Juan, here's Ramela, and it says the coastline is a straight line between them 10 miles apart. Both can see the same ship in the water. So let's say here's the ship in the water. So, you know, with those three things, we can see this triangle that's formed. The angle between the coastline and the line between the ship and Juan, okay, the ship and Juan is this side over here, and it says that that angle is 35 degrees. The angle between the coastline and the line between the ship and Ramela is 45, so there's my 45 degrees. How far is the ship from Juan? So this is what they're actually trying to find. Okay, so that gives you kind of an idea. Now, it doesn't matter how I've drawn this, you know, there's no guarantee that this is a right triangle at all. In fact, we can tell it's not a right triangle, which means that you can't just use the basic sine, cosine, tangent, but you're going to have to use law of sines or law of cosines. Okay, look at number 2. Jack is on one side of a 200-foot wide canyon, and Jill is on the other side. Okay, so a canyon, you know, I'm thinking of like the Grand Canyon. Obviously, that doesn't mean this is the Grand Canyon. So the canyon comes down and then, you know, back up. So Jack is on one side, and Jill is on the other side. How can I make this look like a girl? Does that look like a girl? All right. Hopefully that's not sexist. It says Jack can see the trail guide at an angle of depression. So he must be looking down into the canyon. So remember, we know that this is 200 feet wide. So he must be looking down. We'll say here's the trail guide. He must be looking down at the trail guide. And it says that that angle of depression right there is 60. And Jill can see the trail guide at an angle of depression of 50. So when she looks down at the trail guide, her angle of depression is 50. Again, not necessarily drawn to scale. How far is each from the trail guide? So we're trying to find how far Jack is, I'll call that X, from the trail guide, and also how far Jill is, I'll call that Y, from the trail guide. So it's those two sides that we're trying to find. Okay, so let's see. I think number 3 and 4 are pretty straightforward as far as following the words to get the picture, but let's look at number 5. So airplane A is flying directly toward the airport, which is 20 miles away. All right, so I'll say here's airplane A. They're flying directly towards the airport, which is 20 miles away. The pilot notices airplane B 45 degrees to her right. Well, if I'm flying this direction, then to my right would be this direction. So I'll say here's airplane B, and it says that 45 degrees, so that angle is 45 degrees. Airplane B is also flying directly toward the airport. Okay, so this guy's flying directly that direction also. The pilot of airplane B calculates that airplane A is 50 degrees to his left. So I think they're saying this angle is 50 degrees. Based on that information, how far is airplane B from the airport? So we're trying to find this side of the triangle. Okay, so I think that gives you enough to set up. Let's see. How about we look at number 6? Okay, a plane leaves JFK International Airport and travels due west at 570 miles per hour. So let's say here's JFK. Okay, and if we're flying due west, that means we're going this direction. At 570 miles per hour. So that doesn't mean that this side of this triangle is 570. that means we know how fast they're going. So I'm going to put this in green so we don't think it's the side. We know they're going 570 miles per hour. Okay. It says another plane leaves 20 minutes later, so still leaves the same airport, but 20 minutes later, and travels 22 degrees west of north. Okay, well, if this is due west, this would be due north. Let's pretend like that's straight up. So if they're flying 22 degrees west of north, that means he's actually flying this direction, and this angle is 22 degrees. That would be 22 degrees west of north at a rate of 585 miles per hour. So again, I don't know that the length of that side is 585. I just know that that rate is 585 miles per hour. Okay. To the nearest tenth of a mile, how far apart are they 40 minutes after the second plane leaves? Okay, so first of all, what we're trying to find is how far apart they are. So this is what we're trying to find, but it says 40 minutes after the second plane leaves. So in order to find how long each of those sides is, I need to know how long they've been traveling for. Well, remember this guy, let me do some colors here. This guy had been traveling for 20 minutes when the other guy left, but then it says 40 minutes after the second plane leaves. So this guy is traveling for 60 minutes, which is an hour. Well, if he's going 570 miles per hour and he travels for an hour, that means he has gone 570 miles. So the length of that side is 570. But for this side, he's only traveling for 40 minutes. And he's going 585 miles per hour. So in order to figure out how far he's actually gone, we're going to say he's going 585 miles per hour, but he's only gone 40 minutes out of a 60-minute hour. So in order to figure out how far he's gone, I'm going to need to multiply. So let's see. 585, well, if I could do it, 585 times 40 divided by 60. So he's gone 390 miles. Okay, so he has gone 390 miles. So the length of this side is 390. Okay, so on that triangle, let me kind of finish that triangle. This pink triangle, I know two sides. I'm trying to find the third side. I can't use Pythagorean theorem because it's not necessarily a right triangle. And there's one more piece of information that they've given me that we haven't really used, so you might need to think about the fact that I know that I have a 22-degree angle, and what is that going to tell me about the triangle? Okay. Look at number 7. So for number 7, it says flights 104 and 217 are both approaching O'Hare International Airport from directions directly opposite one another. Okay, so let's think about this. Here's the ground. Okay, here's O'Hare. So there's a plane coming in from this direction. And there's a plane coming in from, okay, that's my plane. There's a plane coming in from this direction. So they're both flying towards O'Hare. Obviously, they're not heading straight down towards O'Hare. They're flying towards that airport. They'll come down in a minute. Let's see. And they're both flying at an altitude of 2.5 miles. So that means this guy is 2.5 miles in the air, and this guy is 2.5 miles in the air. Let's see. The pilot on flight 104. Let's call this flight 104, and we'll call this one flight 217. So it says the pilot on flight 104 reports an angle of depression of 17 degrees and 47 minutes to the tower. So we're talking about the tower that's down here at O'Hare. So when he looks down at the tower, that angle is 17 degrees. Now, we measure angles in degrees and minutes. So just like you would imagine, 60 minutes equals 1 degree. but we're not going to do minutes on here. Let's just round it to the nearest degree. So 17 degrees and 47 minutes would be the same as 18 degrees. So the angle of depression right there is 18 degrees. And then over here it says, and the pilot on flight 217 reports an angle of depression of 12 degrees and 39 minutes. So when this guy looks down at the tower, that angle of depression, if we round it, it's going to be 13 degrees. And it says calculate the distance between the planes. So when we're talking about the distance between the planes, I'm saying from here all the way to here. That's what we're trying to find. And if it helps, keep in mind you could kind of draw this line straight up. So see if from that information you can find the length of that green line. Okay, and then number 8, Matt measures the angle of elevation of the peak of a mountain as 35 degrees. So let's see, here's the ground. We'll say Matt's standing here. Here's our mountain and the angle of elevation. So when he looks up to the top of that mountain, the angle of elevation is 35 degrees. So that angle is 35 degrees. Susie, who is 1,200 feet closer on a straight level path. So Susie is right here. She's 1,200 feet closer. So she's closer to the mountain than Matt. So just when we say 1,200, we're talking about from here to here. That's the 1,200. Okay, so she's 1,200 feet closer. She measures the angle of elevation as 42 degrees. So when she looks up to the top of that mountain, her angle of elevation is 42 degrees. How high is the mountain? So we're trying to find this. Now, I think in this case, even though I know it's a mountain, I think because we're just talking about looking up towards the top, we're thinking of this as being a right triangle. Okay? Let's see, and I think number 9 is pretty straightforward as well. So hopefully those pictures will help you get started on some of these problems.